And here's that thin film on a wire loop. In this way, we're going to watch an effervescent tablet starting off in a two-dimensional liquid film with very little water, and watch the fate of what happens. And you can see that the volume expansion is quite significant here as it takes a small amount of water and liberates the gas due to the chemical reactions involved that make the CO2 gas, and the resultant bubbles expand the whole system. The fate of bubbles in liquid is an important topic for operations in zero gravity, whether you're designing a science experiment or whether you're designing a piece of engineering equipment which is supposed to operate in this environment. And it's really important to understand what happens to gas in liquid and liquid in gas to understand the dynamics of what's happening. And I'm hoping this demonstration will give folks ideas for what might possibly be happening in their systems, and maybe some new experiments can come out of it. And here you can see we have this bipolar bubble structure again with the small bubbles sandwiched in between. And now we're down to one major bubble. And here it looks like the effervescent tablet is, the reaction rate is limited by the supply of water to the tablet. Because it started off in this thin film, the tablet's not completely surrounded by a large volume of water. And you can see here that the chemical reaction is dramatically slowed down as the bubbles are slowly being generated next to the edge of the tablet and moving off into the film. And again, it's possible to have chemical reactions where you are limited by the rate of reactants going into the system. And it looks like that's happening in this two-dimensional film case, in this thin film case. And there the bubble was popped. Now this is a different system that was made similarly to the one we just saw. And just the role of these bubbles moving in this shell of water I thought was interesting, particularly when you start to get them to move by stirring them a bit with a cannula. And as they start to rotate, you'll see that the bubbles move towards the pole of the bubble sphere. I couldn't help but think about Coriolis forces in the rotation of our planet. And this is a top view. This is a sphere of water with the bubbles left over from the effervescent tablet, looking down on top of it, and again the removal of these bubbles. And if you do this carefully, you can end up with almost as clear a sphere of water as what you started with. Now this is a two-dimensional film with an effervescent tablet in it that puffed up and demonstrate removing the bubbles from a film case where it's no longer the dynamics of the sphere. And again, you get it rotating, and the bubbles go to the center of the film, and you can suck them away. But notice as the bubbles are being removed, the flow is accelerating the film. The rotation is increasing towards the center as the bubbles are removed.